Well, today I'm going to talk about my experience with simple DC receivers for 80-meter ARDF. So, I started with this type of receiver, a venerable PJ80. This one is from about 2003. Now, the receiver was initially given to me, but it didn't get much serious use because I was already using a superhet receiver. But I love the keep it simple ideology and was impressed by the fact that the PJ80 could give surprising results. Now, an updated PJ80 is currently available as a kit, and it still makes an excellent project to undertake. However, there are several issues that I had with the PJ80. So, let's have a look at the PJ80 circuit diagram. Okay, so this diagram shows us a very traditional, conventional DC receiver design. So we've got the RF gain and a diode demodulator and 2 stages of audio amplification, and then the VFO, it actually runs at half the receive frequency in this case. Now, it uses a passive diode demodulator, which by all accounts is the preferred solution of most designers as the best means to achieve good receiver performance, dynamic range and all that. But that may be more important for a base station or DX operation. Well, for ARDF there are a few other considerations. Now, because the diode detector is passive, then most of the receiver gain is provided by the high gain audio stages, or 2 stages in this case. Unfortunately, in the PJ80 this results in noticeable microphonics. That's clicks and scratchy noises from using the controls, as well as general knocks and vibrations. Now, obviously that's something you get quite a lot when you use this receiver on foot or running in a woodland. Now, in my elderly PJ80 the control knobs have worn somewhat, so the microphonic noise can be, quite a problem, swamping weak signals and making it very difficult to find weak signals, if not impossible. So for my own designs I much prefer to use the SA612 as an active demodulator. It has a useful amount of gain in itself, and it reduces the requirement of high gain following the detector. Now, another aspect of this design is the sense circuit, and absence of any sort of sense amplification. Well, what this means is that when you take a sense reading, you've got to extend the sense antenna, and you can't really leave it extended because it almost certainly get damaged when you're thrashing through woodland. So it means constantly collapsing and extending the whip. So that's not too great. Now, later on I stumble across an 80-meter design by SM5CJW. Here's the circuit diagram of that, using my preferred detector of the SA612, you might note. Now, this design really impressed me, not particularly because of the circuit diagram, but because of the physical size of the receiver and the general neatness of the design. So here's what it looks like physically. It really does fit in the hand nicely, and the original SM5CJW design had quite a few other novel features, like the winding of the antenna on the ferrite rod, and the sense antenna was actually built into the antenna housing as well. So I just had to build this receiver, and it got me interested into designing a compact DC receiver for 80 meter ARDF. Now unfortunately I couldn't get really satisfactory results with this antenna. I can't remember whether this was a problem with irregular null or sense reading, but I think possibly it was the null that was the problem. So later on I opted for a traditional wound ferrite rod antenna. Now another problem was the drift of the VFO, and in this design it used a surface mount inductor, but the drift problem was never really resolved. So that's one of my pet hates, VFO drift and receiver. So again later I modified the receiver so that I could use a VXO using a ceramic resonator rather than a VFO. So what you see here is the result of that, with a conventional antenna, and inside, if I can open it, we had a ceramic VXO for the oscillator. So this receiver worked quite well, but the major problem was assembling this antenna. Even though it was the conventional form, it really was quite tricky, and I really didn't find a solution that I was happy with. Not a repeatable method I could publish for other builders to follow. And the other slight problem was the limited frequency range of the VXO using a varicap dying tuning. So I decided to have another go at designing the receiver. So this was the result. Now if I compare it with the slightly older design of mine, you see it's not that much bigger, but it's nearly as comfortable to hold. Now I've done away with the external antenna, and it now sits within the main enclosure, something like a bit more like the PJ80 in fact. Now if you have a look inside, you can see that the antenna takes out quite a lot of space in the box. So there's not much room left for the receiver PCB. So it was essential that I use a design with a low component count. So when I first started to look at this, I actually went back to a much earlier design that I had. So this is designed by Tony Green, a GW from Swansea. Yeah, sorry Tony, I can't actually remember your call sign. but it goes back a long way, probably more than the 2008 that's written on here. I've had this in my archive collection for a long time. It must be a candidate for the ARDF receiver design with the lowest component count. And originally, I think Tony built this on a Vero board. I mean, there's not even a need for a voltage stabilisation because the receiver uses a 3.58 crystal oscillator, and the audio amplifier uses a TL431. It's a shunt regulator, whatever that is, but it's pressed to work here as a simple audio amplifier, and it's got very few external components needed to make it work. Now, this oscillator would have been fine a few years ago when the gold standard for 80 meter ARDF was to use 3.58 megahertz. But unfortunately now multiple frequency channels are used in many 80 meter ARDF events. So we move on to my design based largely on this one. Okay, now we have a VXO using a poly Vericon capacitor to pull the ceramic resonator oscillator over a frequency of approximately 3.51 to 3.6 megahertz. So that means it covers the frequency band that's used internationally for all 80 meter ARDF. I've added a voltage stabiliser, a voltage regulator, and also a solid state off-on switch. Now I've chosen to use surface mount components where possible because of the obvious advantage of a more compact design. Now, it does work really good. Don't expect superhead performance, but for classic ARDF, it's more than adequate to do the job. Now, we'll be posting some more videos later to show you how to put one of these together. That's all for now. Thanks for watching.